Charles Finley. I'll be talking to you today. My company name is Transformix Computer Corporation, and what we do is specialize in migrating and modernizing applications. And some people call them legacy applications, which is anything you're using actually these days. We'll get further into that. But we also, in the course of all that, can you imagine you take something that's 40 years old and it runs on some platform that most of you in this room have never heard of before, and then you're going to put it on Linux and Windows, and then no application exists in a vacuum, so obviously it gets data from somewhere else or sends its data somewhere else, so you have to do some kind of integration. You have to upgrade the database. So those kinds of things are the things that we do to keep applications. We don't decide whether or not a person should keep an application. What we do is once they've decided, we help them keep it in a way that makes sense from a time and money point of view. So I use the term metamorphosis in the subtitle here, application metamorphosis, because notice the Eagle changing into an F-15 Eagle. It's a gradual transformation in the picture. Same thing as a caterpillar changing into a butterfly. It's a metamorphosis. It's not an all-at-once change. It's a gradual change over a period of time. So that's what I'm talking about with applications. So I need to establish the difference between migration and modernization because there is no consensus on what that means. In my mind, in the way we use it and the way we'll use it in this talk, if you're going to migrate an application, just think of same look and feel, same functionality, only it's on a different platform. A lot of reasons for it. But one of the key reasons is a platform change, because the way we got into this whole enterprise was because the computer system we worked with mainly was declared obsolete by Hewlett-Packard. And there were a lot of people who had applications running on that they couldn't just get rid of. They couldn't replace, at least in the estimation of their management. These things were valuable enough, gave them some kind of a strategic advantage over competitors, whatever. Like I said, they decide. Now, modernization is a whole different other level. Once you have it running someplace, you want to make it look like what people care about today. And we'll get into what that means, because it means different things to different folks. But it's all like apple pie. I mean, there's not a lot of disagreement about where the world is going in computing. And these applications were developed, as I said, maybe 40 years ago or whatever. They could have been developed last year, but with technology that produced the results you wanted 40 years ago or 20 years ago or whatever, and they no longer meet the application, the organization's need for an application. So modernization then includes things like making this older application work on mobile devices or in the cloud. It's a whole different other level up from just plain migrating the application. So what we do as a company is we migrate applications. We take them from Platform A, Hewlett-Packard 3000, Hewlett-Packard VMS, whatever, some kind of mainframe, and we put them on Windows or usually Linux or some Unix-like platform with a relational database management system. And we also modernize them. And you'll see some of what that means as we go along. So, main job, this is redundant, is that we extend the life of these applications. And what this is all about, this is sort of like AA, I guess. I'm making a confession about what we've been up to in the last few years. I'm going to share some experiences with you about our attempt to take what people like today in applications and apply that to older applications. In other words, we've been trying to find a toolkit or a combination of tools, because that's what our life is all about. We like to use software tools to accomplish objectives. We're trying to find a toolkit, a framework, if you will, that would allow us to take older applications and make them behave like newer applications. And so what you're going to see is some of our motives. You're going to understand some of our motives, and you're going to see where we ended up. Okay, so most people like to think about applications as monolithic. I mean, some department builds an access database, and all they care about is that department. Some department or some division within a company has a manufacturing system. That's all they care about. In truth, what happens in an organization, regardless of the original intent, is too often you end up with these stovepipes. Everybody's got their own island. And so then you have to go out and buy something very expensive called an enterprise service bus, or do various other kinds of tricks for integrating all this data. Even if all you do is exchange files, you create an Excel spreadsheet out of this older, because somebody else is going to want to use that data. And so we end up with all of these issues. We also end up with some other things like that mess. A lot of IT departments, if they've been around for a while, have clutter. But we're not talking about papers out of place or whatever, or a dead cat in a corner. What we're talking about is all these names that some of you in this room probably have seen before. These applications that were great, these either databases or programming languages that were a big deal in their time. And the secret, I mean, you come to a conference like this, and you hear about the cloud, and you hear about all this whiz-bang stuff and about mobile. But we get to see that people have all this old stuff still, and in some cases it's really the most important application in their business, and they're still dealing with that, and they're doing the whiz-bang stuff, so it tends to accumulate, and it becomes a big problem after a while. So we're going to talk about how Postgres can help provide a solution to alleviate some of the duplication of training required, some of the expense. It's not unusual for us to hear that somebody has this application written in this weird language that nobody ever heard of before, and it just broke. And they don't have anybody in the company who knows anything about it. Can we help? So I'm trying to avoid some of that. So as I mentioned before, one of the big problems is here we are today, and where's my, right here. This is what people want applications to look like today. So we have somebody in the company says, let's keep this thing. And yeah, but it doesn't do cloud. It's insecure. We can't, nobody knows the programming languages. So how do we deal with that, plus keep the application? And so what we have is a feature mismatch. We have applications that use older development tools. They exist in their own domain, stovepipe. But it even happens with desktop applications like Microsoft Access. If you ran something at a reasonable sized company, just ran a program that went and looked for Access databases and Excel spreadsheets, what would you find? A lot of surprises. I always hear this. People find a lot of things they didn't know were there. So, you have things that nobody knows even exist or are being used. You have user interface problems. I'm going to show you a pretty ugly user interface here from an application it's typical of a lot of applications still in use today. So the applications are not meeting organizational needs, and we're going to propose a way to help get those applications into a more modern state. So what we're talking about is building a bridge between the legacy features and modern requirements. So here's summarizing it all. We're going to replace some databases. We're going to replace some developer tools and programming languages with modern ones. And we're going to future-proof some applications. Future-proofing means we're simply going to make it so that if somebody needs to put a RESTful API on top of an old application's data or functionality, we'll be able to do that. And no surprises, cornerstone, Postgres. Very good choice for a foundation for salvaging some of this logic and these applications. And now, if you go looking for frameworks, Wikipedia, you're going to see a long list of all these frameworks, and each one claims to be God's gift to development, right? And if somebody's willing to pay you, you can spend your whole life just evaluating them. Okay, well, we've spent a lot of time, way too much time evaluating them, and one we like is called Axelor. So we're going to present that. And we don't own it. It's out there. It's open source, but you're going to see why I'm showing it. And all right, so then you need some modernization, some migration tools to get the data and the applications over to another platform, and you're going to want to modernize them. So that's really what we're talking about when we talk about application metamorphosis. Okay, so there's an application. How many people in this room have seen and worked with applications that look like that? So-called green screens. Okay, and in some cases, they're still around. And they're in wide use. I mean, an awful lot of the world runs on applications that are like that. Okay, but here is that same application modernized with Axelor. And now we're going to revisit this, not necessarily only that application, but the tool set. And you're going to see why that's a big deal. Okay, so what does that look like in practice? What we have here is the application is migrated in such a way that it thinks it's working in the old environment. So we have this trick where we create a driver that intercepts all the calls that are in the original programs. The programs have to be tweaked because the COBOL may be different on the target platform. And then we have an API. We add an API to the database management system. But this is just a Postgres database. That's all it is. So if somebody else with some commercially available off-the-shelf tool using ODBC, JDBC, whatever, RESTful APIs, wants to get at the data, they can get at it on day one. And the application data can be used by either, as well as used by other outside applications that are not related. So you can have extensions to the original application, supplemental code, and you can have other user departments, for example, or using the same Postgres data. So you've already made some progress. And then if we put this on top, Axelor, you'll see why all of a sudden we have completely transformed the application. But notice, the original application is still here. So everything we liked about the application, its stability, its business rules, we haven't creamed the business. We haven't put ourselves out of business. All we've done is added some capability here in a safe way. So here's our strategy. We're going to move from our program-centric way of development to database-centric with Postgres. We're going to add features to the application environment in a progressive series of solutions. You'll see what I mean by that in a minute. But we're also going to address a programmer productivity problem. How many people have developed programs with text editors, just rudimentary text editors and COBOL compilers and stuff like that? Okay, a lot of people in this room have done it. Some of you have never seen that before, and you'd probably quit if somebody tried to make you do that. It's hard. It's a lot more work. But there is a way that you can enhance these applications with modern tools and modern toolkits that will greatly improve the user experience. And punchline, you can make it so that somebody who just came out of college can work on an application that's 40, 50 years old. Okay. So we're talking about a solution that's meant for maintenance and enhancement and development newer applications. So I couldn't help it. I think a lot of you are probably familiar with this song, the Meghan Trainor song. It's all about the bass. So it is. It actually, database is really important in this thing I'm about to talk about. And Postgres is really qualified to do that. So, as I mentioned, we're going to do a metamorphosis approach. We're going to look at what it takes, what benefit you get by just migrating only the database to Postgres. And then if you migrate the application and the database, you get some additional benefits. And then if you, modernization, database modernization, I like to talk about as a separate topic because it's kind of a big deal. And then application and database modernization, which is where we finally end up. And so this is meant to just illustrate how you get better. You get more and more towards your goal as you move up from each one of those stages. Okay, so making no change is harmful to your health, and I won't go into the details of that because we cover it when talking about the benefits of having moved to another level. So first, a database-only migration, where the existing applications continue to work as they always have. The user can't tell a difference. The screens may look the same and all that, but we can extend the applications. We can add SQL access if we need to. We can add screens to the application environment that just go directly at the data and bypass the older APIs, and other applications can access the data. That's important because if you can take business objects or something, whatever you like as a report writer, and have somebody just go after a SQL database instead of ISAM or Turbo Image or RDB, all these old database types, you've made a big improvement. So when I started programming, record level access was the rage. I mean, you do everything for yourself in the program. You do type checking, any error checking you need to do, relationships between the data, all that stuff is done in your program. With a database, a relational database, it's data-centric. And the database does a lot for you. Even on day one of this migration, the database is doing a lot for us. But then when we get into database modernization, we can see how we can do an awful lot by just taking advantage of features that are already in the database management system. So that's really the big gain here when you migrate the database. So what does that look like? What it looks like graphically is the application still runs the same as it did. However, so that's the bottom part of that diagram I showed before. However, all the other APIs are available to the developer and for use with tools. Okay, so now let's migrate the application. Why do we want to do that? Well, if the platform is obsolete, if it's no longer supported, the hardware is no longer supported, the OS is no longer supported, we have things outside compliance rules like Sarbanes-Oxley and all that, and we may need to go ahead and lift the application off. And even if we only do that, we have done enough compliance to where the feds stay off of our back, or the SEC in some cases. So it's a like-for-like migration, kind of the minimal migration you can do. But you may change programming languages, you may or may not. You may go from a COBOL compiler that cost you $30,000 a year in maintenance to GNU COBOL, which costs you nothing in maintenance, on Linux. So who knows? Things like that. But users sit down and they don't need any retraining. I mean, it's minimal. It's like a couple hours and the users are pounding away at the same keys. Same functionality as before. But, as I said, it's easier to extend the application because now, here's a case in point. Let's say we migrate, this is like real stuff. We migrate this application with 400 COBOL programs. And all of them run really, really fast, or as fast as they did on the original computer. However, 5 of them are like dogs. I mean, something that took a half hour on the original platform takes 4 hours, literally. Well, that has to do with how the database is accessed. So then if we use the power of the database and we change for those 5 programs, we change how the database is accessed and use pure SQL. Anybody want to guess what the difference in performance would be? All right, we had a half hour. How about less than a minute? Because all that was happening in that other program was a lot of essentially set theory, and the database engine handles that for you. So all of a sudden you've done a big win here. And all this, you don't have to understand all the details here, but essentially what we do in a migration is we create a phony environment for the application where it thinks it's still running on the original platform. Not moving. Let's see. Oh, there we go. Okay, and this is a part that I don't really want to bore people with. I just want to show it's a non-trivial exercise to move programs. You know, here's the COBOL source code. We move it to some other kind of COBOL source code. It may have a proprietary form file. We have to find a solution that re-implements that on the target platform. The database schemas, we get into Postgres, the message files, which are like message queues, we have a solution for that. And job control language, we have a solution for that. And all of that is the application environment. So we phony up the application environment, and we're able to move the application. So, but that's what's involved essentially at a high level. So now it gets a little bit more interesting when we start talking about database modernization. Okay, this is something that probably most of the people in this room don't appreciate, because you've always worked at least with a relational database management system. But if you've been exposed to flat files and ISAM and hierarchical database management system, when I start talking about some of these other things you get with a relational database, you say, oh yeah, that's different. So we're gonna, now, a key thing here is that we're not gonna change any parts of the legacy application we don't wanna change. But we can add new functionality to the application once we get these features in place. And so we're gonna need database migration tools, and we're gonna need modernization tools and a workbench to do that. Okay, this is a cartoon. Essentially, reminds me of something that happened to me once when I was in the Marine Corps. First sergeant, I came off the rifle range on a Friday night. First sergeant said, oh, can you, we had an IBM System 360, and he said, can you take all this information from this new system and put them on punch cards for me? I'm serious, this really happened. And I said, why? What do you need to do? And he says, orders just came in, Pueblo incident. There were no Marines on the West Coast. The last 2 regiments had been shipped out for the Tet Offensive, and there were literally no Marine infantry troops on the West Coast. He said, so we have to demobilize 29 Palms, the base I was at, and I need to sort, through the personnel files and only get, single men under a certain age, and I need to have that by tomorrow morning. And I said, stand back, I know RPG. So while I was on the rifle range, I learned this, at that time was a new language, and I said, well, why don't I just give you the report? I gave him the report in less than an hour. I got to learn this RPG thing. So the tools matter, and that's a very important part of making our life easier. So what are we talking about with features in RDBMSs that really make things slick? Indexes, foreign keys, composite keys, searching on partial keys. You try that in some of the old file storage systems, and it's if you can do it, you might have to buy a very expensive add-on third-party product, or look forward to a lot of programming. But all you have to do is create the composite key on Postgres. And it goes on and on about indexes. You can do a whole tutorial, 3-hour tutorial on just what you can do with indexes. Full text searches. Views are magnificent, and that you can all of a sudden sort or get combine multiple tables together and only present that to the program. That saves a lot of programming. Triggers, assertions, cursors, user-defined functions, stored procedures, and later, when we get into the modernization thing, object relational mapping, and not only SQL, or the way people say it is NoSQL, which Postgres has that capability now because of some new features that were added, I guess with 9.4 or something. So all of a sudden, your development toolkit just grew exponentially. And if you just tweak the database, you can get your applications much further faster. Okay, so, I found a statistic someplace where it said that could reduce the amount of effort associated with writing a program by 80%. Okay, so the final thing, which is application and database modernization. So assume that you have done all the previous steps. Now, all this you can do this last thing first if you want to. I'm just showing a progression how you exert a certain amount of effort and you get a lot of benefit. That's really it. But so now we're going to take it to the next level, and we're going to make things exponentially better. And we're going to use a toolkit, a framework called Axelor. And well, let's see, actually, I should stick with my foils. I have a problem with that. Okay, so this just talks about using better tools to do the job. Guy with a lawnmower. No, I got my own tools. Let's push more here. So we found Axelor. We went looking, as I said, we spent years looking for different kinds of approaches. We tried lots of different approaches. We found this thing in France called Axelor. And it's a rapid application development toolkit. Browser-based development, mobile development capability. You get mobile development capability as a corollary. I mean, you build your screen, and then you try to access it with a mobile phone, and it adapts. Tablets, all this stuff, all this neat stuff. And so you can build Web 2.0 applications that are fast and secure. You can host it in the cloud, and the primary database they use is Postgres. Okay, so what it didn't do, it wasn't designed for what we wanted to use it for. It did not use existing databases. So we tweaked it so that we could use existing databases. And the forms-based development tools where you could do drag and drop type things to build a form. It didn't have that, so we added that. However, what it did have, and that's why it's in green, is some nice applications, ERP, CRM, and other kinds of things, calendars, and all this stuff that you can use in your own application. So you can check it out. I mean, like I said, I have no interest in the thing except that we found that it was a convenient thing for us to use once we did our magic with it. And we care about all of these open source, wonderful things that are the foundation of so many different frameworks today. AngularJS for user interfaces, build tools, Gradle, reporting, Jaspersoft. A lot of these things we were using already in other applications, Hibernate for object relational mapping. So it's built on top of that stuff. So now what we have is this consolidated model. We can take legacy applications, we can take Microsoft Access, DBase, Btrieve, whatever, and put them in the same target framework, which greatly simplifies our life, because now all of a sudden, at a minimum, what you've got, in addition to the high productivity and all this stuff, is you got somebody in a company who understands how to use this stuff. If it breaks, somebody can fix it. You can go out and find skills out in the ether there. You can hire people who've seen this stuff before. You went from DBase what to, or what's a paradox? You know, well, it was actually this slick thing. I remember 35 years ago, it was the latest and great. Well, it's not now. And we can't find anybody who knows it. You know, so oh yeah, well, this is just all a bunch of standard stuff. So lots of people can work with it. So what do we got? What we've got is a rapid application development toolkit. We've got, in our environment, which I haven't talked to yet, it runs with a web application server, nice modern database management system. We've got a framework, and so the thing that my company added were application-specific tools, my company and partners. So that was our goal. That was what we were aspiring to, being able to run it. And now, I need to spend a little time on this. Okay, you don't ever have to retire this part. This is what you started with. However, if you choose to all of a sudden disconnect it one day, you put the Axelor screens on top of it, it can all disappear and the users won't know it. So the paper is going to be available to you online and through the conference, and also I have some things here where you can download it from my site. But this is all the things that Axelor does, and this is all the stuff that we do for an HP 3000 migration, and it's all available and it's all using Postgres. So that's just another way of showing that same model. So I don't know how I'm doing on time here. I got time. So let's see. If I do this, oops. Somewhere in this whole mess this is a video and it's not. Let's see, is it going to come up? Yeah. Okay, so here is, this is just meant to show you the power of Axelor. Remember the 40-year-old application, right? Okay, so here what we've done is incorporated this little stupid time entry example into the Axelor framework. And now we are able to edit tables and things like that. But it's incorporated. So here are some off-the-shelf Axelor things: project management, sales management, address management, an ERP system. Whatever we want to use from Axelor, we can use their modules, and we can use our modules. Furthermore, we could take our Access databases and put them in the same framework. And we're asserting control over all that mess. We're cleaning up our clutter with this model. Okay, and then I guess this is showing the mobile phone thing. All I did was used Google Chrome, and I said, show it to me in a browser, and it did. And I thought I had a tablet one there too. I don't know. I think that's it. Let's move on. Okay, so this is, it was redundant. It's just another way we integrate is we can actually run a screen with all of the back-end code that's necessary for running a screen, modernize the front end. We can take a program, take the head off of it, and actually put a different front end on it and run it back on the host. things like that. And I'm not going to go through this particular demo. All right, so this is where we are. We went from just simply migrating the database. And we can do that with an Access database. I have examples. And then we can farm out the forms and the queries and various things, put those in a relational database management system, completely transform the thing into something that works with Axelor and Postgres. And something that we've never seen before. As long as you're storing data and retrieving it, we can work out a solution. And we don't do this all from scratch necessarily. Somebody may already have part of the whole solution where they go ahead and they parse all of those old artifacts. But at any rate, we get to the point where we can migrate that. And in the case of Access, you can actually have put the database in Postgres, use ODBC, and continue to use the Access code if you want to. Lots of choices. But all of a sudden, you have given other people access to the data. You've made it more secure. You've done a lot of things for the data. And you're not vulnerable to a lot of the ills of some of these desktop applications. Modernizing the database, that takes us a long way towards really giving user departments what they want. And once we do this, we're in a whole different world. But we're making it so that everything we had before still works. So anyhow, that's my contact information if anybody's interested. Now, I didn't mean to just ramble like that. I wasn't sure how long this was going to take. But anybody have any questions? Does this raise any issues? Or anybody want to tell me that I'm full of it? I don't care. Nothing? No questions? Nothing? What? I'm sorry. Go ahead.
You had on a slide that Axelor was AGPL?
Yeah.
Right? Does that mean you have to open source the plugins?
No, it means that for the core products that you use, if you make modifications to those, you have to make that available as open source. But anything else that you develop on your own is yours.
Even on the FARO GPL?
I'm sorry?
Even on the FARO GPL, the AGPL?
Well, you mean if you use the AGPL inside of your own application code? I mean, because the way you would normally use this, you wouldn't need to put it in your actual, the way applications are built, you would not need, it would just be part of the runtime. The unique proprietary portions don't have to use Axelor core. You'd have to get into the architecture of it to see, but it's not, I don't think it's not a big risk. I'm sorry, you were.
So you kind of very casually mentioned a lot of governmental agencies. So would you talk a little bit about compliance when you're doing a transformation like this?
In terms of?
Well, you mentioned SEC and other things.
Oh, okay. Okay, let's go. Okay, well, look, I'll be specific then. I'll talk about, now I won't give you the name of the customers, but I'll tell you the situations that were addressed. Okay, you have this large Fortune 500 company that had an application written in a language called Transact that paid hourly employees. And it was on an HP 3000, but the HP 3000 was no longer supportable. So had the system had a massive failure, the government could have gone after the corporate officers for essentially dereliction by not, so I think that's Sarbanes-Oxley. So they had to get it off in a certain period of time in order to put it on another platform that was still being supported. Okay? So that's one issue. Another one is, I'm not sure which government agency this is, big insurance company. Two of those actually, two different applications. In one case, they retired a certain computer system, replaced it with another one, and all the data involving the people who had premiums for that insurance has to be kept for a certain number of years. It has to be available. They have to be able to produce reports from that data when a demand comes in. So what we did in that case was we took the database, took it from HP Turbo Image to IBM DB2 on an AIX machine, and because that was their main platform, and now that's where it sits. And so now they're able to go at it with conventional tools, and they're able to produce whatever's necessary. So another one, line of business, big insurance company, Midwest, line of business discontinued. For a certain number of years, they have to keep access to the policies. Different kind, I don't even remember what kind of insurance it was, but so there are these regulations where at least if you put the database on something somebody understands, you're complying, but in some cases you actually have to run the application on another platform. Does that answer your question?
Kind of.
What?
It seems like there are a lot more hoops for some of the financial things
Yeah.
that you're discussing.
Well, I don't know about all of those. I'm only telling you about specific things we've had to deal with and motivations people have had.
So that deals with why they were upgrading their system, but what about anything you had to deal with in designing the system, changes?
Okay, that's a good question, because we don't care what the system is used for. We don't do any design. We're done when it does the same thing on this platform that it did before. If we had to move data sources to a relational database management system, it doesn't matter. It just needs to function the same. So we have a very simple, tight specification to meet. So, yeah. Okay, so any other questions?
Have you ever integrated PG REST for REST interface?
I've done, personally, yeah, I've played with it, but okay, it's not in production. I have played with it, that's it. So, but the important part about what you just raised is that that's something that's available to you once you get on Postgres. It's not available on some of this older stuff. I don't want to keep you over, I'm early. All right, so we're good. Okay, any other questions? Complaints? Issues somebody wants to deal with, some old stuff that's sticking that they're wondering about? Okay, well, thank you very much for attending, and I hope you got something out of this.